Hello. The following example is where we're going to start solving our first word problem. This word problem is going to result in a quadratic equation. In order to solve these types of problems, you have to read the problem. I know that sounds very obvious. However, in order to solve a problem, you really need to understand what it's asking for. So I'm going to go ahead and read this problem. A piece of machinery produces rectangular sheets of metal such that the length is 3 times the width. Equal-sized squares measuring 5 inches on a side can be cut from the corners so that the resulting piece of metal can be shaped into an open box by folding up the flaps. If specifications call for the volume of the box to be 1,435 cubic inches, find the dimensions of the original piece of metal. Okay, we've read it once. Then we really look for what it's asking for. That's usually at the last part of the problem. Here, it says, find the dimensions of the original piece of metal. Now, the original piece of metal is a rectangular sheet. So what I'm going to do is I'm going to draw a rectangle, or a reasonable facsimile of one. Okay, so I have a rectangle. What I need to do is I need to define a variable or two. Now this can be considered the length and this can be considered the width, or vice versa, it really doesn't matter. But if you look at the beginning, it says the length is 3 times the width. So I'm going to let W equal the width. That means that 3W will have to be the length, because the length is 3 times the width. So if this is the length, that's 3W, and if this is the width, that's W. Now then, this says equal-sized squares measuring 5 inches on a side are cut out from the corners. In other words, what's happening is you're getting something cut out here from each corner. Okay. And each one of those is 5 inches to a side. Notice what I'm doing here is I'm just writing down in pictorial form what it says in the problem. What's going to happen after they cut out the 5 inches for each square is they're going to fold up these remaining flaps, and what's going to happen is this rectangle that you see here that I'm making in dotted form, this is going to be the base of the box, and each one of these is going to be the sides of the box. If you need to, get a piece of paper, cut out the corners, and fold up the flaps, and you'll see what's happening here. Okay, the only other piece of information that they give us is that the total volume V is 1,435 cubic inches. Now the volume of a box is length times width times height. Now the length that they're talking about is the length of the base. And realize that's the length that it's talking about. The width is also this width here. It is not the original width and it's not the original length. The question is, what is this length here? Well, 3W has something to do with it. Notice because I'm cutting out 5 inches there, and I'm cutting out 5 inches there, that I'm cutting out 10 inches from each side. So the length is actually going to be 3W minus 10. The same thing for the width. The width, 5 inches there, 5 inches there, so it's actually W minus 10. The question is, what's the height? The height is actually going to be this 5. That's how tall this box is going to be. So H is actually just 5. So the volume is the length, which is 3W minus 10, times the width, which is w minus 10, times the height, which is 5. And that's all equal to 1435 cubic inches. So 1435 is equal to, I'm going to go ahead and FOIL this out. That gives me 3w squared. 3w times negative 10 is negative 30w. Negative 10 times w is negative 10w. So negative 30 minus 10 is negative 40w. And negative 10 times negative 10 is positive 100. But all of that is still being multiplied by 5. So I need to distribute that 5 into all of that. So I get 1435 is equal to 15w squared minus 200w plus 500. If I subtract 1435 from both sides, that's going to give me a quadratic equation. So subtract 1435 from both sides, that gives me 15w squared minus 200w. 1435 and 500 have a difference of 935. So that's negative 935 is equal to 0. Now notice 15, 200, and 935, they have a common factor. I know that they have 5, they might have 15, so I'm just going to do 5 first. So divide everything by 5. Now I could have done this up previously, but this is what I'm doing here. So 3w squared minus 40w, 935 divided by 5. 5 goes into 9 one time, so 5 from 9 is 4, 43. 8 goes into 43 8 times, leaves me with 3. 3 brings down the 5, so that's 35, so it goes in 187 times, equals 0. 3 does not go into 40. Therefore, 5 was the greatest common factor. This is the equation you want to solve. So w is equal to, well, the problem is that this is a quadratic equation. So negative b plus or minus the square root of b squared minus 4ac all over 2a. What I'm going to do is I'm going to do b squared minus 4ac first. B is negative 40, so that's negative 40 squared minus 4 times a, which is 3, times c, which is negative 187. Negative 40 squared is 1600. Negative 4 times 3 times negative 187. Well, there's two negatives, which means I have a positive. And 4 times 3 times 187 is 2,244. So 1600 plus 2,244, well, I have the 44 at the end. 2 plus 6 is 8. 2 plus 1 is 3. So I have 3844. 3844 actually is a perfect square. If you type in the square root of 3844 on your calculator, you will get 62. So that means that w is equal to negative b. If you go back up here, negative b is positive 40 plus or minus the square root of 3844, all divided by 2 times 3, which is 6. So that's 40 plus or minus 62 all over 6. Now I'm going to just go to the right here because I'm running out of space again. So I have 40 minus 62 over 6 and 40 plus 62 over 6. And if you were to simplify this, 40 minus 62 is negative 22. Negative 22 divided by 6, simplified, is negative 11 over 3. 40 plus 62 is 102. 102 divided by 6 is 17. I'm going to reject this negative 11 thirds. It is a mathematical solution, but it is not a physical solution. The reason it's not a physical solution is because this is a distance, and distances are never negative. There's no such thing as the side of something being negative 11 thirds inches. Now, I know that W is 17. So because W is 17, go back to the beginning, we said the length is 3 times the width. So that's 3 times 17, and 3 times 17 is 51. So, because we have 17 and 51, that means that the dimensions are 17 inches by 51 inches. However, don't just leave it like this. Because the problem is a word problem, you should be writing your solution in a sentence. I'm going to say the dimensions of the original piece of metal are 17 inches by 51 inches. And there's my solution.